So there are two main types of glands. Give 1 second. My system is trying to respond. Okay, that's good. Okay. So two types of glands. You have what we call an endocrine. Give 1 second. My pen is responding slowly. Let me see. You know, when you're dealing with technology, these are some of the issues. Okay, let's see. Okay. All right. So the first type of gland is known as the endocrine. Endocrine gland. Okay. Now, endocrine gland means that that gland has a duct. So has a duct. So duct is the opening through which it releases its secretions, what we call the secretions. So if this is the, no, hold on. I made an error here. Endocrine gland has no duct. This is no duct. So another name for it is a ductless gland. Ductless gland. Okay. So it will look like this. The vessels will be going in and out, blood vessels going in and out of it. Okay, so no duct. Take a blood vessels all over. Has a lot of blood vessels going in and out. Okay. And then two, the other one is an exocrine. Exocrine gland. The exocrine gland, these are glands with ducts. They have ducts. They have ducts. So they have an opening through which the gland releases its material. So this will be the ducts. Okay. If this is the surface, and there's a gland. All right, so they have ducts. Okay. So we want to talk about endocrine glands. So the endocrine gland here, we're talking about, they are those without ducts. So without ducts. All right. Now the secretions are the material that they release. So the secretions are released directly into the blood. All right. Now the endocrine glands secrete hormones that regulate various metabolic activities in the body. Okay. And here's a diagram that summarizes the different endocrine glands that we have. Okay. You can be given this diagram on a test, and then you'll be asked to indicate what each of them do. You know, like one, you'll be numbered like 1, 2, 3. I'm going to show you an example in the book very soon. Okay, 1, 2, 3, 4, 5, and then you have to identify them in the function. All right. Good. So let's do a quick overview of the endocrine gland before we look at that particular question I'm talking about. So one of the glands, the first gland we want to talk about is the hypothalamus. The hypothalamus. All right. So that is somewhere here, the hypothalamus, somewhere there. Yeah. And below that, you're going to have the pituitary gland, right? So on this diagram, the right diagram that's here. Okay. So what does the hypothalamus do? The hypothalamus secretes a number of hormones. One way you can remember the hormones that it releases is the word releasing hormone. If you see releasing hormone attached to that hormone, it comes from the hypothalamus. So it produces 8 main hormones. 8 hormones. Okay. And the hormones, some of them stimulate the pituitary gland to produce other hormones, right? So example of the hormones is what I have here. Thyroid releasing hormone, follicle releasing hormone, and so on. Let's go down. I'll show you some of the things that releases. All right, so if you look here, and the hypothalamus, the one, you have Theratroping releasing hormone, right? This acts on the pituitary to release the thyroid stimulating hormone. So that's a short form for it, a TSH for short, thyroid releasing hormone. So it stimulates the thyroid gland to release its hormone, right? They have 2, growth releasing hormone, GH, right? Growth releasing hormone. This acts on the pituitary gland to release its growth hormone. So GH, RH, usually, and RH, right? Releasing hormone. They have gonadotropin releasing hormone. This acts on the pituitary gland to release gonadotropin. And gonadotropins are the follicle stimulating hormone, FSH, and the luteinizing hormone, LH. Right? Those are the follicles, the 2 hormones that stimulate the pituitary to release. We'll talk about them shortly. Then also have gonadotropin releasing hormone, CRH. This one acts on the pituitary to cause it to release the adrenocorticotropic hormone, ACTH for short, ACTH. We'll talk about that as well. And they also have oxytocin. Oxytocin, this is what causes the uterus to contract, so uterine contractions, and also helps with secretion of breast milk during lactation. So that's oxytocin. Okay. And then it also releases dopamine. Okay. Dopamine is a neuroendocrine transmitter. It acts as a neurotransmitter. It also stimulates the release of other hormones. Then we have something called vasopressin. The common name for it is Anti-Diuretic Hormone, ADH for short. All right. This acts on the kidney to prevent the loss of water through the urine. So it regulates water loss from the body via the kidney. And then the other one they have is called somatostatin. Somatostatin, this one inhibits the release of the growth hormone, right? So these are the 8 key hormones released by the hypothalamus. What you have to remember is the fact that most of them act on the kidney, most of them act on the pituitary gland, to cause it to produce more hormones. That's why we call them releasing hormones. The releasing hormones. Okay. Stimulates the pituitary to release more hormones. So that's what the hypothalamus does. Okay. But we'll concentrate more on the pituitary gland, So the pituitary gland, as I said, that's below the hypothalamus, just below the hypothalamus. I'm going to draw it a little bigger here. So the pituitary gland, if you have the hypothalamus here, the pituitary hangs under it like this. So this is the hypothalamus. And the pituitary has 2 parts. Has anterior part, which is anterior pituitary. And it has a posterior part. 2 parts for the pituitary. Remember that the anterior part produces hormones. So here, it produces hormones. That's what you should remember for the test. And then the posterior part, it doesn't produce hormones. It just stores hormones produced by the hypothalamus. That's what it does. It stores hormones produced by the hypothalamus. Okay, so remember these two things. Okay, now there are two main hormones produced by the hypothalamus that are stored in the pituitary gland, and those two hormones are the oxytocin, hold on. And sometimes the pen becomes slow. Okay, let's see. Okay, she's working now. So that's oxytocin. It's not acting up again. Okay, should be fine now. So one is oxytocin, and then the second one is the ADH. Anti-Diuretic Hormone. Okay, ADH. Those are the two hormones stored in the posterior part, right? All the other ones will be produced by the anterior part. So let's go through some of them quickly here. Okay. So I have that the pituitary gland has an anterior hormone producing glandular portion in the posterior part, which is called the neural portion. All right. It's an extension of the hypothalamus, right? And then two hormones, oxytocin, ADH, are produced by the hypothalamus and are stored in the pituitary. That later releases it. Then the 4 of the 6 pituitary hormones are the tropic hormones, right? We call them tropic hormones. Tropic hormones because they regulate the function of other endocrine glands. Okay. So here are the hormones produced by the anterior portion. Okay. Because they regulate other glands, the pituitary is known as the master. Some people call it the master gland. If you heard with the master with the orchestra, master gland, then there's a pituitary gland. It controls other glands. Okay. So growth hormone is one of them, GH. So growth hormone, that is what. So one of them, growth hormone. The name tells what they do. That's what we can remember. It stimulates growth of all tissues in the body, especially the skeletal muscle and bone, right? It also helps to mobilize fat. It stimulates protein synthesis, and then it also inhibits glucose uptake and metabolism. Okay, those are the functions that the growth hormone does. If you have too much growth hormone being produced during early part of growth, the person becomes, because the growth is increased, the person can become a giant. Okay, become a giant, and that's what we call gigantism, right? Whilst if the person produces a low amount during the growth stage of life, then the person is not going to grow fast. Then they with stunted growth, and that's what we use the word dwarfism. Becomes become a dwarfism, right? So that's deficiency. of growth hormone. Okay. Now, if the person has already grown, let's say adult, we already finished growing, and then you start having an increased production of growth hormone, the only way you can grow is to like expand, your body will start expanding, right? So the bones expand laterally. And that is what is known as that one is called acromegaly. Acromegaly. I don't have that written here, but the word is acromegaly. I'm going to put it on the side here. Acromegaly. You see this word, it means that the growth there's increased growth hormone production after the growth spurt. So the person expands laterally, lateral growth. So the bones, let's say the jaws become so huge, and so on. Acromegaly. So these are some abnormalities that you can get when growth hormone is overproduced or underproduced. Okay. Then the second one is the thyroid stimulating hormone, TSH. TSH. So that's number 2. TSH, thyroid stimulating hormone. Now, the thyroid stimulating hormone would act on the thyroid gland, and to cause the thyroid gland to produce the thyroid hormones, which we'll be discussing shortly. So, thyroid stimulating hormone. See, thyroid. So that tells you what it does. Okay. Then the other one is the ACTH, adrenocorticotropic hormone. ACTH. Okay. That one stimulates the adrenal gland, the cortex of the adrenal gland, to release the cortisols, the stress hormones. And we'll talk about that soon. Okay. And then you have the gonadotropin, the gonadotropins. And the gonadotropins, we have the follicle stimulating hormone, the FSH. So that those are the FSH, and then the LH. FSH. So number 4, FSH, and LH, luteinizing hormone. So these hormones regulate the functions of the gonads in both sexes. So the follicle stimulating hormone, this one will stimulate sex cell production. That's what it does. And then the luteinizing hormone stimulates the production of hormones in the gonads. Okay, so gonadal hormone production. Okay. Then the last one is prolactin. You have prolactin. So 5, prolactin. PRL for short. So prolactin stimulates milk production. Okay, it stimulates milk production. Okay. So if you see these hormones, they are produced in the anterior part of the pituitary gland. Okay, and then oxytocin and ADCH in the posterior part. Okay, so those are things that you want to remember for the test, and then their functions. Okay. All right. So the second part here, I've just spoken about it. The posterior part, what it does, oxytocin, it stimulates the uterine contractions. We said that already during labor and delivery of babies. It also causes ejection of milk in nursing mothers. So uterine contractions, that's one. If you're reviewing uterine contractions, that's one key word. And then milk ejection in nursing mothers, causes the milk to be expressed. Then the second hormone is the ADTH. As I said, this stimulates the kidney tubules to reabsorb and conserve water. Okay, so water retention, that's a function. This results in the production of small volumes of highly concentrated urine and decreased plasma osmolarity. Now, osmolarity has to do with how much salts are dissolved in the liquid or in the fluid. Okay, underproduction will lead to what we call diabetes insipidus. Diabetes insipidus, where the affected person passes a lot of diluted urine. Okay. So that's an abnormal condition whereby the person does not produce enough EDH. So they're losing a lot of water, called diabetes insipidus. Okay. Remember, this is different from diabetes mellitus. Diabetes mellitus is sugar, low, like high levels of sugar in the blood can regulate. If the person cannot regulate high levels of sugar in the blood, the person gets diabetes mellitus. That's different from this. Okay, this insipidus. Okay. Okay. All right. So those are the hormones produce the pituitary that I want you to think about when you are studying. Then the thyroid gland. The thyroid gland. Now the thyroid gland produces the thyroid hormone. So if you go back to the diagram, the thyroid is somewhere in the neck region. So have a mental snapshot of this picture, just take in your mind. So the thyroid gland is right there. Thyroid gland. And then you have the parathyroid. There are 2 pairs on this side, so 4 parathyroid on the thyroid gland. Those ones are tiny glands. So the thyroid gland, what does it do? It produces the thyroid hormone. The thyroid hormone. The thyroid hormone, there are 2 types: the thyroid or T4, and they have T3, right? If you remember your anatomy physiology, T4 and T3. T4 is known as thyroxine, and T3 is known as the triiodothyronine. Triiodothyronine. Okay. Now the active form is this one. This is the active form. T4, active hormone. Okay. And then T3, this is the inactive form, right? So before T3 can be used, how to convert it to T4, all right? Okay. And the main function of the thyroid hormone is to control metabolism in the body. So it controls the metabolic rate. Okay. So remember, function of this is to regulate metabolic activity, regulate metabolism. So that's the function of the thyroid hormone, the thyroxine. Okay. Now, let's talk a little bit about thyroxine. Now, the thyroxine needs iodine. You need iodine for its production. So that's why it's a triiodo. Triiodo means iodine. 3 iodine is needed here. So if you take thyroxine, let's get rid of this. Give 1 second, some people are waiting. Hello, Jasmine. Can you see what's going on? Okay. Everybody can see the screen, what I'm writing.
Right now, no. I mean, I see the active.
Yes.
What you wrote before. Yeah.
But it's okay now.
Are you writing something right now?
No.
Oh yeah, so what you wrote before is fine. Yeah.
Okay.
I can see it.
Just making sure everybody's seeing what I'm writing. All right, good. Okay, let's see here. All right, great. So for thyroxine, thyroxine. Thyroxin, sorry. So thyroxine. For thyroxine, we said you need iodine. So one, iodine is needed for its synthesis. So you need iodine for synthesis of thyroxine, right? So if somebody is deficient in iodine, then you have low production of thyroxine, that it will not function well, okay? And that leads to a condition known as goiter, where the thyroid gland becomes swollen. So deficiency deficiency. Deficiency leads to goiter. Goiter, that means swollen thyroid. The thyroid becomes big. If you get a chance, you can Google a diagram of it and see. That can become very huge. Once you give them iodine, over some time, it goes down, and that's why they get treated. But we don't see that. It's not common in the US here, because if you look at the salt, they add iodine to it. That's the reason why they add iodine to the salt, to prevent deficiency of it, to reduce goiter production. That's why it's not common in the Western part of the world. But developing countries is quite common. Okay. So the function is to regulate metabolism. Okay, remember that. Okay. Then the other thing I want to mention here is the fact that if somebody is deficient in thyroxine, two words I want to bring up. The person will have what we call hypothyroidism. I believe you've heard that word. So hypothyroidism means, hypo means low, right? Low. So here, low level of thyroxine. So they have low metabolic rate. So you can always work this backwards based on the function of the thyroxine. So low metabolic rate, So the person is not eating much, but the person is putting on weight. So you got that, you have weight gain. They gain weight, even though they are not eating a lot. Okay. Low metabolic rate. Then they cannot tolerate heat, so low heat tolerance. They can't tolerate a lot of heat. Usually when you're cold, you generate heat, to warm up. But because their metabolic rate is low, they cannot tolerate high levels of heat. So let's say that the room, you're sitting in the class, the temperature in the room is okay, but then they will tell you that it's too cold here, while the temperature is okay, because they are not generating a lot of heat for themselves, And then they're also a little bit sluggish. They are sluggish because they don't have enough energy, They cannot focus very well. So you have low mentation. Very low focus. They can't focus on things. Okay. Or because they lack energy, Then those who have high levels, let's talk a little bit about them. which is a hyper root of words, hyperthyroidism. For hyperthyroidism, a quick overview of that. This is high level of thyroxine. Okay. Because they have high levels, their metabolic activity is very high. So high metabolic rate. High metabolic rate, you know. So because of this, if they eat a lot, but because of the high metabolic rate, they don't put on weight. So here, eating a lot, but they low weight gain. So here, weight loss. Because the metabolism is high. Okay. And because the metabolism is high, they generate a lot of heat. They generate a lot of heat. You know. Generate lots of heat. Okay. So because of that, the room temperature is fine. But they will tell you that the room is too hot. The room is too hot, you know, because they're already hot. So that's what happens in this group of people. Okay. All right. So this is a quick overview of what the tyrosine does and some abnormalities. Okay. All right. So you talk more about this when you do pathophysiology in your nursing class at the abnormalities. They'll talk more about that. But this is just a quick overview for you to think about some of these things. Okay. Then the other thing that is released by the tyrosine is calcitonin. Calcitonin, that's the next one here. Calcitonin. So calcitonin is produced by what we call the parafollicular cells of the thyroid gland, parafollicular cells of thyroid gland. The function of the calcitonin is to reduce, it decreases the calcium levels in the blood. Calcitonin decreases the calcium levels, right? So remember that part, reduces the calcium level in the blood. Okay. So the thyroid has produces two hormones, thyroxine and calcitonin. Tyrosine, calcitonin. Okay, remember those two things. Okay. Now let's talk about the parathyroid gland, the parathyroid. Now the parathyroid gland, as I said, they are located on the thyroid gland. Okay, and the function is to produce the parathyroid hormone, PTH, parathyroid hormone. The function of the parathyroid hormone is to increase the calcium level in the blood. So when calcium level goes down, it will cause it to increase in the blood. Okay. Remember that the calcium is stored in the bone. If you have the calcium is stored in the bone, right? So when the level is high in the blood, then calcitonin will be released and it will push the calcium back into the bone, right? When the level is low levels, let's say this is a blood, we have low levels of calcium, then the bone will have to break down to release calcium into the blood. It breaks down to release calcium into the blood. Okay. And then this will be the action of the parathyroid, PTH. The parathyroid hormone will break down the bone and cause it to release calcium into your blood to increase the calcium levels. Okay. So that's what it does. In other words, it works antagonistically to the calcitonin. Okay. They're opposites of each other. Okay. So know the function of calcitonin and the function of the parathyroid hormone. Okay. And then the other thing is the hormone we want to look at, the pancreas. The pancreas. So if you go back to the diagram, the pancreas is right there. So there's a pancreas here. Okay, pancreas. So the pancreas is one of the glands that you have to know also very well. It has a dual role. So the pancreas both an exocrine and endocrine function. Okay, they like that question too. Which of these glands has those functions? So it's an exocrine gland as well as an endocrine gland. Okay. So the exocrine portion, we'll talk about that under digestion. We'll talk about that. Okay. But what's the endocrine function? The endocrine part is where it produces insulin and glucagon. Insulin and glucagon, two of the common hormones that it produces. The other hormones that it produces, but we'll stick to these two for now. Okay. The glucagon is produced by what we call the alpha cells, right? And the function of glucagon is to increase the glucose level in the blood. Increases glucose levels in the blood. Okay, so glucose level is low, then to cause the liver to break down the stored glucose, which is glycogen, and to release glucose into the blood. Whilst insulin is released by the beta cells of the pancreas, and the beta cells, by the beta cells. Now, it reduces the glucose level in the blood. So when glucose is high in the blood, the insulin will bring down the glucose level. So reduces glucose level in the blood. Okay. And how does it do this? It does this by increasing the rate at which glucose is taken up by the cells and metabolized, right? That's how the insulin does it. So if there's deficiency of insulin, then that's where we have diabetes mellitus. Okay. So insulin deficiency, diabetes mellitus. Okay. So those are the two things to remember about the pancreas. It's both endocrine and exocrine. Both. Okay, that's a gland that has both functions. Okay. And then it produces insulin, which reduces the sugar level in the blood, and glucagon, which increases sugar levels in the blood. Okay. And then the other hormone gland that I want to look at, the gonads. The gonads. So the gonads, there's the ovaries and then the testes in males, ovaries in females, testes in males. Two main hormones in the ovary, that's estrogen and progesterone. Estrogen and progesterone. Okay. So the estrogen stimulates maturation of the female reproductive system and development of the secondary sexual characteristics, while the progesterone works with estrogen in establishing the menstrual cycle. Okay. Then the male, the testes of the male produce testosterone. So that's a hormone produced in the male, testosterone. Okay. And the testosterone promotes maturation of the male reproductive organs and development of the secondary sexual characteristics, and also production of sperms by the testes. Okay. So that's a function of the hormone, testosterone, produced in the male. Okay. And then the other gland is the pineal gland. The pineal gland usually is almost around the same, too far away from where the pituitary and then the hypothalamus is, just a little bit behind that, and it produces what we call the melatonin, the hormone melatonin. Okay, and this influences the daily rhythm, such as sleep and wake patterns. So the melatonin, it controls what we call the circadian rhythm. If you heard about the circadian rhythm, yeah, that's what it does, a sleep and wake pattern. So that's another word we use, circadian rhythm, sleep and wake patterns. Okay. And this is influenced by light. So light influences the circadian rhythm. Okay, light. Yeah. So that's why people are encouraged, if you work, let's say in the night, it's good to turn the light off, few minutes at a time, so at least it doesn't disturb your circadian rhythm, your sleep and wake pattern. And then the last one I want to talk about here is the thymus. Okay. Usually the thymus vanishes as by the time the child is born. The thymus is almost not there because it has already performed its function. So if you go back to let's go back to the diagram again and look at where the thymus is supposed to be. So this is a thymus, the yellow thymus right there. Okay. So the thymus produces what we call thymopoietin. Okay. The function of the thymus is to school the T lymphocyte, right? So T lymphocytes, that's where the word T comes from, the lymphocyte. So they go to school in the thymus to be trained so that they can recognize yourself. You don't, so they can identify your tissue as you and not a foreign tissue. That's what the T cells does. The T cells damage foreign tissues. So the thymus train them early in life so that if they see your tissue, they don't damage them. But if they see a foreign one, then they can attack them and so on. Okay. So say it is an important organ of the immune system during the developmental stages of life. It vanishes by the time of birth. So this is where the T cells mature. So we say that the T cells or T lymphocytes they are schooled here to recognize the self. Yeah. So there's a theory that those who have autoimmune disease, their T cells were not well trained in the thymus, so they are not able to recognize their own tissues, and they end up destroying their tissues. That's one theory about the T lymphocytes. I'm sorry, about autoimmune diseases. Right. So this is a quick overview of the hormonal system, that you can use to answer questions. We'll go to a textbook after this, and then I'll show you the diagram that I'm talking about. They have a diagram on this. So let's look for that diagram in the book. Look at page 223. Page 223. It's a diagram number 29 and 29, 30, and 31. All right, if we are all there, then let's look at it together. It says, questions 29 through 31 refer to the following diagram of the human endocrine system. And they have the diagram over there, numbered 1 through 8. And then 29 says that the function common to the organs of this system is A, reproduction, B, secretion, C, respiration, and D, excretion. So which one do you think is common to all of these? Anybody can? B, yeah, secretion. Secretion. So the secret hormones. All right, number 30. Which of these organs controls the amount of calcium in the blood? Which one controls the amount of calcium in the blood? And then they have A, 1, B, 2, C, 3, and D, number 6. So which one is labeled that controls calcium?
C.
C, number 3, correct. All right, because those are the small dots on the thyroid gland. So that's the parathyroid hormone. Parathyroid hormone. So that's number 3, correct. And then 31, it says, which of these organs has the added function of producing digestive enzymes? Added function of produce digestive enzymes. In other words, they talk about the exocrine part. There's added function of exocrine function. Because the digestive enzymes are produced in the exocrine glands. I have A, 2, B, 5, C, 6, and then D, 7. So which one has both endocrine and exocrine function? That's what we're trying to test you on. So which one will you choose? Anybody?
Which question is that?
31. Number 31.
D.
D7.
D, 7, yeah. 7, that's the pancreas. The pancreas. So the pancreas has both functions, and the added endocrine and exocrine functions. Pancreas. Correct. All right. So that's how sometimes they ask you the question, the diagram, and they have to identify which one performs a particular function. Right? Great. So if you know everything that we discussed today, you should be able to answer questions on the endocrine system. I think we've covered enough of that for the test. Any questions so far on the endocrine system? We spent a lot of time on that. All right, so far so good. Okay. All right, so another system. Let's look at another system. I have here one of my past diagrams that I drew. The digestive system. We'll do a quick overview of the digestive system. Okay. So the digestive system, we have the hold on for a second. Okay. So the digestive system. Now let's begin with the mouth. Okay. Now what you have to remember, the digestion starts in the mouth. All right. Digestion starts in the mouth. And the process is known as mechanical digestion, chewing of the food, mechanical digestion, breaking down to pieces. They have chemical digestion. That's done by saliva. Okay. So the saliva contains an enzyme called an amylase. amylase. So the amylase, remember in the mouth you have amylase, enzyme amylase. And then amylase breaks down starch to simple sugars, right? So amylase, yeah. It's an enzyme. Okay. It breaks down starch into simple sugars. So if you remember, there was a question that I asked some time ago from the book, which said somebody chews crackers slowly and then it starts tasting sweets. You know, why is that possible? It's because you have the enzyme amylase that breaks down the starch into simple sugars. Okay, that's a function. So that's why it tastes sweet. Okay. Then the food is swallowed. It goes down in the esophagus. All right. Then the esophagus, remember that in the esophagus, the key word I want to remember is the word peristalsis. Peristalsis. That's the food that is formed in the mouth is called a bolus. Right? The bolus is the food, the ball of the food that the tongue rolls and mixes with the saliva. And it's pushed down the esophagus and then moves down like the snake-like movements, the contractions and relaxation of the muscles to push the food down. It's what we call the peristalsis. Peristalsis over here. Peristalli. Peristalsis, SIS. Okay. So it goes down. And then once it goes down, it enters the stomach. In the stomach, we have also mechanical and the chemical digestion. The mechanical digestion, the smooth muscles, like they contract and then end up breaking down the food further and mixing it up with the juice in the stomach, the gastric juice, right? Now, the chemical in the stomach is the acid, ACL. So the acid, the function of acid is to, it destroys some of the bacteria in the food. And then also, another function of the acid is to activate the enzyme called pepsinogen. Okay. So pepsinogen is an inactive form. Pepsinogen, inactive. So when there's acid present, ACL, it becomes what we call pepsin. And pepsin is the active form, active enzyme. And the function of the pepsin is to digest protein. So what it does is protein digestion. Digestion of protein. Okay. So digestion of protein starts in the stomach. That's what you have to remember, that it starts in the stomach because you have the pepsin in there, right? Digestion of the carbohydrate starts in the mouth because of the amylase. Okay. Now the pepsin is produced by the cells called the peptic cells. So here I have pepsin breaks down proteins into amino acids. That's the first thing here. Then ACL, we'll talk about that again already. Then you have the mucus. Why is it that the acid doesn't destroy the stomach lining? It's because you have the mucus gland, secretes mucus that protects the lining of the stomach. Okay. And then we also have some other enzymes like lipase that break down lipids in the stomach. But the main thing that at least happens in the stomach is protein digestion. That's a key thing that happens there. These ones are like minor things that occur. Yeah. And then you also have bicarbonate, sodium bicarbonate, that neutralizes the acid, especially when it gets towards the duodenum area. You know, it tries to neutralize it over there. Okay. But the key thing to remember is that you have pepsin, the acid, the pepsin, and then the mucus protecting the lining for now, for this part. Okay. All right. Then the food, the substance that is produced when the gastric juice is added onto the food is known as the chyme. So the chyme, the word chyme here, chyme, that means it's a mixture of gastric juice and then the materials that went to the stomach, chyme. Okay. So that goes through the duodenum. Duodenum is the first part of the small intestine. So now let's talk about the small intestine. So the small intestine, three key things they have to remember the small intestine. And those are the three parts: duodenum. The second part is the jejunum. And then the third part is the ileum. Okay, three parts of the small intestine. Okay. So the small intestine is where we have absorption of digested food. Okay. We also have, if you take out the duodenum portion, that's where it's somewhere here, around here. This is going to go like this around there. So over here, you have the pancreas opening up into the duodenum. Then you have the bile duct also opening up in the duodenum. Let me see if I can draw it a little bit on the side here. So it looks like something like this. It is a stomach. So the pancreas will be somewhere here. And the pancreas, the pancreatic duct opens into the duodenum over here like that. And then the gallbladder will be here. Then it also opens up into the duodenum around here. Okay, it's a gallbladder. Okay, so they open up the duodenum. Okay, so that's where you have the word trypsin. Trypsin is produced in the pancreas. So the pancreas releases its pancreatic juice together with a lot of enzymes. You know, the pancreas has all the enzymes. It has amylase, it has protease, it has trypsinogen. So they digest protein, digest carbohydrate, digest fats. They're all released into the duodenal part, the duodenum, or the small intestine. So digestion of all the food substance occurs in the duodenum. It keeps on occurring there. Okay. Then the gallbladder also releases its substance known as the bile. The gallbladder bile. So when we go to gallbladder here, the gallbladder, what it does is stores bile. You know, it doesn't produce bile. Remember, it stores bile. The bile is produced by the liver. The blue part is the liver. So the bile produces, and then the bile is produced there and stored in the gallbladder. Okay. And the function of the bile is to emulsify fat. So we use the word emulsify. So when we talk about bile, the key word I want you to remember is the gallbladder. And then that one key thing is bile storage. Remember that. And then 2, remember that the bile helps emulsify, bile emulsifies fat. Okay. What do you mean by emulsify fat? Emulsify fat, think about soap and oil. Oil will not dissolve in water, right? It will not mix with water. But when you use soap, you wash something that's stained with oil with soap. Now you see that it ends up mixing with the water. That's what happens in the body. It's difficult for fat to mix with the waters, but when you have bile in there, it helps to break down the fat into droplets that will mix up with the water for easy digestion. Okay, that's what the bile does. It emulsifies the fat. So remember that keyword, emulsification. Helps the fat to mix up in water, breaks it down into droplets. Okay, so that's the function of the bile. So if you take out somebody's gallbladder, it means that the person will not be able to digest fat. Remember that key fact too. You cannot digest fat well. And removal of the gallbladder is what they call cholecystectomy. If you've heard that word, cholecystectomy, that is removal of the operation to remove the gallbladder. Okay. So if the gallbladder is removed, the person cannot digest fat well. Okay. And then the other thing that will happen if you remove the gallbladder, there are 4 vitamins that need fat to be able to get absorbed. And these are vitamin A, D, E, and K. So vitamin A, D, E, K. So the fat soluble vitamins, we're going to fat soluble. Vitamins A, D, E, K, ADEC for short. Will be affected. The gallbladder is removed. Because they need fat to help them to get absorbed. Okay. And then one thing that you remember with the small intestine, which is very important, is the presence of what we call the villi in the small intestine. So villi, when we get here, very important to remember the villi. Okay. So in the ileum, remember villi, very important. If you forget everything at all, one villi present. Singular is villus, right? Villus singular. So the villi, the function of the villi is to increase the surface area for absorption. Villi increase the surface area for absorption of digested food. So think about this towel, the thread standing out on the surface of the towel. That's how the villi looks like in the small intestine. They increase the area of absorption of the food. They like that question too. So villi in the small intestine, absorption, increase the surface area. Okay. All right, so this should be good for the small intestine and the gallbladder. So the other part will be the large intestine. So remember, the large intestine, the main function of the large intestine is to store the waste as feces, and then also so absorption of water. Okay, that will be the large intestine, storage of feces and absorption of water. So large intestine, storage of feces, and then absorption of water. Okay. All right. The appendix, if you take appendix, usually has no particular function, but it's considered to be part of the immune system. It produces some, what do you call it? It's called a lymphoid organ. But basically has no important function in the body. Okay. So it can easily be removed without any consequences. It rather causes more problems sometimes. Okay, so this is a good overview of the endocrine system. I have a summary here. Another name for the endocrine system, remember, is the alimentary canal. That's another name, alimentary canal. So they ask that question somewhere in the book, alimentary canal. All right, and this is a summary of what I've said. Everything's right there. All right, so key points 1 to 12. When you get a chance, you read that all that I've discussed. It's down there. Right. Any question on digestive system overview? Okay. All right. So next one, let's look at the genitourinary system, urine production. Urine production. Okay. So we have the kidneys, and then we have the ureter, which carries the urine to the bladder. And then from the bladder, so the bladder stores the urine, and then we have the urethra that comes out, the duct that comes outside urethra. So note the difference between ureter and urethra, two different things. Okay, so there's a gross anatomy of it. But what is the unit of the unit of urine production? So units of urine production, and that's what we want to look at. The basic unit of the kidney is going to be what we call the nephron. The nephron is a basic unit. It's the nephron. That's the basic unit of the kidney. That's where the urine is produced. And then the nephron, if you take the nephron, it looks like this. So that looks like that. And then it goes up and down like this. And then have the hairpin loop structure. And then up and down. structure, and then gets to what they call the collecting duct somewhere there. So these are basic units. Okay. They have blood vessels that come in, break down to capillaries, small, and then comes out again as a blood vessel. Okay. All right. So what you have here, this is known as the blood vessel that brings the blood in is known as the efferent vessel. The one that takes the blood out is known as the efferent vessel. Then they break down the blood vessels here is what we call the glomerulus. Glomerulus. The network of capillaries here. And the glomerulus, which is a network of capillaries, sits in the cup-like structure here. This cup-like structure is what we call the Bowman's capsule. Bowman's capsule. Okay. So the Bowman's capsule opens into this up and down structure that goes up and down like this, we call it convolutions. So this part here is close to the glomerulus, so we call it proximal convoluted. Proximal convoluted tubule. Okay. Then this hairpin loop is known as the loop of Henle. Loop of Henle. And then another convolutions here, up and down movement. So this is called the distal convoluted tubule. And then the last part here, tube here, is called the collecting duct. Collecting duct. Okay. So that's an overview of the nephron, how it looks like, the nephron. Okay. So how is the urine produced? The urine is produced by three main processes. So what you have the urine going through here. The blood goes through the efferent vessel. And then here it is filtered. There's filtration here. Filtered out. And it comes, whatever is left comes out here. Okay. So the first step in urine production is what we call filtration. You have to filter the blood. So filtration is the first step. First step is filtration in the glomerulus, right? So when you filter the plasma or they filter the blood, right? The solid part cannot come out. Only liquid part and some dissolved substances is what comes out. So you don't expect to have red blood cells, white blood cells, and those big cells in the urine. If you see that in the urine, then there's a problem with the glomerulus. It means there's a problem here with the filtration system. So only the filtrate, which with the plasma with the dissolved salts and glucose and other things, they go out here. So in the proximal convoluted tubule, what happens is that you have reabsorption. The good part of the blood, or the filtrate is reabsorbed. It goes back into the blood. So the second step is known as reabsorption. You reabsorb the good parts. Okay. reabsorption, that's second thing. Okay, so the filtrate travels through the loop of Henle, and when in the loop of Henle, you have water being reabsorbed. Okay, what happens is that the first part here, sodium goes into the system. So sodium goes out along the first loop, the descent, we call the descending part. So what happens is that you have a lot of salt concentrated here. So as the water goes up here, it's water was reabsorbed here, H2O is reabsorbed along this line. Remember, water always follows the salt. You know, and this is what we call the counter current mechanism. You don't need to know too much of the details for this test, you know, but it's called a counter current mechanism. Sodium pushed out at the first loop, the descending loop. So as the water gets to this ascending loop, it's drawn back into the body. Okay. And then when you get to the distal convoluted tubule, that's what we have what we call secretion. Secretion, the distal convoluted tubule. So that's what we call secretion. That's the third step. Third step is secretion. Let's see. Sometimes the pen freezes when you're writing. Okay, it's back. So the third step is secretion. 3 steps. Okay. So first you filter, the blood is filtered. Second, there's reabsorption of good substances back into the system in the proximal convoluted tubule, and the third part is secretion. So these are the 3 steps for urine production. Okay, so the secretion involves, like, if you're releasing, let's say if there's too much acid in the body, then you have to push the hydrogen ions back into the tubule to be passed out in the urine. If it's too low, it will be absorbed. You know, sodium, hydrogen ions were absorbed. You know, if the body is too much alkaline, or then you have to push out, let's say, all this sodium and other things to push in, and so on. So it depends on the state of your body. You either release that ion into the urine or you absorb it, you know, and all occurs in the distal convoluted tubule here. Okay, so remember these 3 steps for urine production: filtration, reabsorption, and the secretion. Okay, I think I have a summary of that here too, and in the diagram form. So that's the explanation. Okay, and then the urine that is produced goes through the collecting duct. The collecting duct, and the collecting duct will eventually open into the ureter. Okay, so this a good summary in the diagram form. You know, if you get a chance, look at the diagram. Okay. Summarizes all that I've said here. Okay. All right, present reabsorption of water, ions, and all organic nutrients, the nutrients in the proximal convoluted, distal convoluted tubule, secretion of ions, acid, drugs, toxins, you know, and then variable reabsorption of water, sodium, ions, calcium, under hormonal control. So the distal convoluted tubule, this is where you have the ADH acting, the ADH that we spoke about, anti-diuretic hormone, will act around the distal to control how much water leaves or goes in. Yeah. Okay, all right. So this is a good diagram if you can look at it after the class. Okay, all right. So that's overview of the urine production. The big system that we try to cover. Okay, all right. All right. So another big system we want to look at is the blood. I think we did a blood last week. We did the blood. So this is a quick overview in the diagram form, what we discussed last week. red blood cells, platelets, white blood cells, how they look like. Neutrophils, eosinophils, basophils, lymphocytes, monocytes, they all fight infection. Different types, and then we talk about different types of the different functions. So we'll skip this one. But we want to look at the cardiovascular system. Cardiovascular system. A quick overview of that. Now, to discuss the cardiovascular system, usually I like to use this diagram. Okay. Usually I'd like to draw this diagram that looks like this. So I'm going to draw the lungs. This diagram is so helpful if you go to your nursing school. You can use it to predict a lot of abnormalities. So it is the lung, then I'll represent the heart using a box. We know that the heart has 4 chambers. So I'm going to use a box to represent that, the heart. Then you have blood vessels that bring blood from lower part of the body let's draw this here. Blood from lower part of the body that goes to this part of the heart. We'll talk about it. Blood from the head region. That also brings blood vessel from here. Okay, and from here goes there. Let me change this to this here, sorry. Okay. So today the pen is responding so slowly. Let's see. Okay, I got it. Okay, so Ali, this is a quick overview. All right. So as we have here, these are chambers of the heart. So 4 chambers, the upper part on the left side here. This is a left, this is a right. So right atrium. This is the right ventricle. Then we have the left atrium, and then left ventricle. Left ventricle. Okay. So the blood from different parts of the body will come in here. Let me use a red color. A blue one. Okay. So blood comes in from the head region, then into the right atrium from the lower part of the body, all into the right atrium, right? And from the lower part of the body, the blood vessel here is known as the inferior vena cava. So that brings in deoxygenated blood. So the blue one is deoxygenated blood, flows in from the lower part of the body. And then from the head region, this is the superior vena cava. Yeah. So all these ones, the blue indicate they're all that's deoxygenated blood, right? Deoxygenated blood. Oxygen has been used up by the body. Okay. And then this right atrium pumps the blood through, there's a valve here known as the tricuspid valve. Okay. Which allows the blood only to flow in one direction. Okay. So this pumps the blood through the tricuspid valve, and then the blood goes through the blood vessel known as a pulmonary. So this is a pulmonary artery. Pulmonary pulse, PL artery. Okay, so the pulmonary artery carries the blood to the lungs. So this is a lung, and the oxygen is added to it in the lung, and then the blood now becomes oxygenated, and the oxygenated blood passes through the vessel. This will be the pulmonary vein. So this is a pulmonary vein. Pulmonary vein. So the pulmonary vein brings the blood to the left atrium, and the left atrium pumps the blood. There's another valve here. The valve here is mitral valve, also known as a bicuspid valve. Bicuspid valve. Okay. And then the left ventricle will pump the blood through the biggest artery in the body, known as the aorta, and then goes to other parts of the body, all other parts of the body. So this is a general diagram that you can use to answer questions on the cardiovascular system. So the red color here indicates blood that oxygen has been added to. So it's oxygenated blood. Oxygenated blood on the left side. whilst on the right side, we have deoxygenated blood. Okay. Yeah. Now, there are some exceptions I want you to note here. One, usually arteries carry oxygenated blood. Let's say all arteries carry oxygenated blood except the pulmonary artery. Okay, the pulmonary artery is carrying deoxygenated blood. So it's an exception. Likewise, all veins carry deoxygenated blood except the pulmonary vein. So the pulmonary vein here is carrying oxygenated blood. So it's an exception to what veins do. Okay, and an exception to what arteries do. So let's write down something to remind ourselves. So all arteries carry oxygenated blood except the pulmonary artery. And then two, all veins carry deoxygenated blood except today my pen is slowing me down a lot. Let's see. Okay, so all veins carry deoxygenated blood except give me a few seconds. Let's see. Okay. So all veins carry deoxygenated blood except the pulmonary veins. Okay, so these are exceptions, to the rule. They're always good for multiple choice questions. All right, so this is a quick overview of the cardiovascular system, right? Now, why did I say this diagram is helpful, the schematic diagram here? Now, you can use this to predict, let's say, heart failures, right? Heart failures when you're doing your nursing. So let me show you how you can use this diagram. When I meet some people, they still tell me they have my diagram. I say, that's good. Right. Now, let's take something like heart failure, right? Let me just stimulate your brains quickly here. There are two types of heart failures, what we call like main types. You have left heart failure, right heart failure, when your heart fails to pump blood, right? And how would the symptoms present? If there's a heart failure, let's say the left side is not pumping, left heart failure, and the left side is not pumping blood out well. So let's go here. This is blocked, it's not working. Left heart is not working. Okay, let's say this is not working here. This is not working. Let's see. Give me 1 second. Let me see if I can change the battery on the pen. It's responding so slowly. Okay. All right, let's try this. Okay, so let's say the left side is not working well. So it's blocked. It's not pumping out the blood, right? So it's blocked here. So if it's blocked here, it means that blood is coming in, but it cannot be pumped out. So what happens? There'll be pooling of blood backwards. So all this becomes filled with blood. It's like clogged. Okay. So there's going to be blood in the pooling in the lung. So the person comes to you, the person cannot breathe well. So you're drowning in your own blood. That's the way we describe it. The person is drowning in his own blood. So there's difficulty breathing. You know? And this even gets worse when the person lies down. So the person will come, Madam Nurse, I can't breathe very well. When I lie down in the night, it becomes worse. Because when they lie down in the night, the more blood comes along. You know, so they feel like they are passing away. Yeah. So listen to the lung with a stethoscope, and then you hear what we call crepitations, like fluid in the lung. It's sounding like type of thing. You know, that's how it sounds. Like bubbles opening up. That's how they'll present to you. So if you see fluid in the lung, and you can hear those crepitations, that sound that I made, then you know a person is having left heart failure, right? Now, if this is not treated and this keeps getting worse, then the blood keeps pulling backwards. So you have blood going to the pulmonary artery, backlog. So you're going to eventually get to the right ventricle. So the right ventricle also becomes affected. And then once the right ventricle becomes affected, they have right heart failure. Okay, right heart failure. So if you have both the left and the right heart failing, they have what we call congestive or combined heart failure. Okay. If you don't treat this, what's going to happen? The small pulling of blood backwards, the right side has failed, so the blood backwards, like traffic getting, blocking traffic backlog. So eventually, you're going to have fluid in the whole body. So there'll be fluid in the tummy, the stomach, what we call it, the abdomen. There'll be fluid in the legs will be swollen, and so on. So if somebody comes with swollen legs, fluid in the abdomen, then you know that the person has right heart failure as well. If you have fluid in the abdomen, swollen legs, what you call it, like that's what we call the edema, pedal edema, and there's no fluid in the lung, then you have right heart failure. If you have fluid in the lung, swollen legs, and abdomen, then you have combined heart failure. So this is how you can use the diagram to predict the different heart failures. So this is just to stimulate your mind a little bit for your clinical practice. Great. Any questions on the systems that we studied so far? So at least we've covered the big systems. Okay. All right, so that's a summary of the cardiovascular system, the diagram here. Okay, great. All right, so one other thing that I want us to look at is how to analyze diagrams. How do you analyze diagrams, right? So we'll go to the book and we'll do some discussion. There are a lot of diagrams that they'll give to you to analyze. When you see those type of questions, don't get scared and don't skip them. Always do them. The answers are always in the question. And that's what I'm going to show you soon. always in a question. They can be long statements, long paragraphs. Just read them. The answers are already there within a question. You don't have to have any knowledge of what's going on. So there are three areas I want you to focus on, and that is on data analysis, analyzing the data, and 2, interpretation of graphs and pictograms, and then 3, making conclusions and inferences from the information that is given. Okay. So this is just a quick diagram that shows you the scientific approach, observation and curiosity. You observe something, you become curious, and then you form what you call hypothesis out of the situation. Then you test your hypothesis. If your hypothesis is true, like it holds for some experiment that you've done, then you can come out with what you call the theory. You can make a theory out of that. Okay. If it's supported by a lot of the higher experiments. Okay. Then if the theory, you do more tests on a theory, and the theory always holds, no matter what you do, then that theory becomes a law. Okay. Like a law of gravity. No matter what you do, if you throw something up, it will always come down. So it's a law. So it's a law of gravity. Okay. Then when you perform an experiment, there are 2 things that I want you to think about in this experiment that you do. You have what you call the experimental group and a control group. So control versus the experimental group. Now the experimental group will be the group that receives the treatment or the independent variable, what you're testing for. And then the control group, it will serve as the standard of comparison or the constant. So the independent variable is either not present or set at a standard value, right? So I have an example here. Let's say we want to see whether fertilizer is good for the growth of plants. So in the experiment, you have the plant, and then that plant will receive fertilizer. Then the control, you have the plant, and maybe you just water it, but you don't give any fertilizer. So that will be the control group. You omit what you want to test in that group. So let's say that if I want to find out whether the workshop is effective, that we're doing now is good, I have to have a control group, 2 groups. Those students who will have the workshop and students who will not have the workshop. Then I'll expose both groups to the same test. And afterwards, I'll see which group does well. So those who will not receive the workshop will be the control group that we can use for a case like I've described. Okay. So in the exercise that we're going to do, we want to think about control group and experimental group in questions, okay, when they give to you. And then also making conclusions and analysis. Okay. So with that said, I want us to go to the textbook to think about all that we've done so far. Great. Right. So let's take our books and then we'll go through some questions. Anything new that comes up, we'll discuss that along the line. Okay, so let's open to page 218. Page 218. Let's look at number 5. 218, number 5. It says, the alimentary canal is associated with the A, spinal cord, B, digestive system, C, urinary tract, D, birth canal. Alimentary canal.
B, digestive system.
Digestive system, correct. So that's digestive system, as we said. Very good. Number 6. The numerous villi in the small intestine serve to A, secrete enzymes for digestion. B, absorb water from dissolved foods. C, secrete hydrochloric acid to dissolve food. And then D, provide greater surface for absorption. So the function of the villi.
D.
D, yeah. So greater surface area for absorption. That's what it does. D, good. All right. Number 9 through 10. That's based on the diagram. So we're going to do an analysis from the diagram. Okay. So look at the diagram for that question. Number 9 through 11. So question 9 through 11 refer to the following graph, which shows the amount of 3 gases in automobile exhaust at different airflow ratios. So 9 says the exhaust from the engine contains most nitrogen oxides when the airflow ratio is approximately. So based on the diagram, what do you notice? 12 to 1, 16 to 1, 18 to 1, 20 to 1. So look at the graph.
Is it B, 16 to 1? That's where the highest nitrogen oxide level is?
Correct. So 16 to 1, right? Just to the right of the line, then the dotted line. So 16 to 1. What is the highest amount of the highest ratio for the nitrogen oxide? Okay, that's correct. I hope everybody is okay with that one. Just beyond the dash line, the dotted line. The 16 to 1. Good. Then number 10. It said this graph provides an explanation of, so A, engine knock. B, lead content of gasoline. C, diesel engine operation. And D, air pollution. Air pollution. So what do you think? And the answer is in the diagram.
Air pollution?
Air pollution, correct. Air pollution. So if you look at the graph, you have on the y-axis, it has emission concentration, right? That tells you what's happening. Emission. So if emission, exhaust, yeah. Automobile exhaust. So you're polluting the environment, the air pollution, correct. And number 11 says the emission of carbon dioxide is probably not included in the graph because carbon dioxide is A, included in the hydrocarbons, B, not affected by airflow ratio, C, natural part of the atmosphere, and D, part of the carbon monoxide. Why didn't they put it on the diagram? Why didn't they show it? Why do you think they didn't show it? Make a good guess.
Is it a natural part of the atmosphere?
All right, if it's a natural part of the atmosphere, the other ones are all part of the atmosphere as well.
Oh, okay.
Right, so that would not be too much of a good conclusion here. So let's try another one. It's B, right? It's because it's not affected by the airflow ratio. That's why they did not, you know, if it was affecting it, they would have shown it there, but that's not affected. So it's not going to make any sense putting it as part of the graph. So it's not affected by the airflow ratio. So it's B. Yeah, that's the answer here. Okay. All right. Let's look at number 14. Number 14, I didn't get to talk about this last week. So I'll mention that now since we've seen this diagram. So I'll talk about it briefly and we'll continue. So for number 14, we have to have the idea of energy. That's one thing I didn't talk about last week. And there are two types of energy that I want to focus on, different types of energies. But I'll focus on two main ones. One, kinetic energy. And the second one will be potential energy. When you say kinetic energy, it's energy due to motion. Energy due to motion. If the object is moving, then it has what we call kinetic energy, right? And in physics, let's say kinetic energy, let's call it Ke, is equal to 1/2 times the velocity squared times the mass. Let me write it out this way: 1/2 times the mass times the square of the velocity. Okay, half mv squared, mass times velocity squared. So this is the formula for finding kinetic energy in physics: 1/2 times the mass times the velocity squared. So if something is moving, it has kinetic energy. And then two, the other one is potential energy. Potential energy is energy due to the position of the object. So energy due to position. In other words, if something has a height, then above the ground, then it has potential energy. Okay. So we define potential energy by the formula. PE is mgh. mgh. So it's the mass times gravity. So that's the mass. This is acceleration due to gravity. And then the h is the height of the object. Okay. So we'll just focus on these two energy for now. Yes, thermal energy, electrical energy, and other things. We'll talk about thermal energy another day. But these two main ones. Okay. So if I have a book on a table, the book will have kinetic, will have potential energy because of the height above the ground. If the height is 0, then the whole thing is 0. You know, potential energy is 0, and so on. Okay. So this question comes in the form of diagram sometimes. So in the form of diagram, you can think of an object like a ball here. When I push the ball down the hill, at this point, when it's resting, it has max potential energy if it's resting. So this is like ground level here. Here, the kinetic energy will be 0 when it's resting. As it begins to fall down or roll down the hill, energy can be changed from one form to another. You can destroy energy, or you can convert from one form to the another, right? So in between the total energy here, you have potential energy plus kinetic energy as it goes, as it's rolling down. That'll be the total energy. And then once it hits the ground level, now because the height is 0, here the potential energy will be 0. And then you have your maximum kinetic energy here. Maximum kinetic energy as it hits the ground level. So that's why it moves very fast. When it moves so fast, when it gets here, it's very fast velocity. So this is a summary of how potential energy is changed from one form to the other. Okay. You can also come in the form of the pendulum. When I take the pendulum, the same thing, but I take the pendulum hanging here, I can swing it up there. When it is resting, this is the resting stage. When it's resting here, the potential energy here is maximum. Kinetic energy, no, what did I say? Here, potential energy here is 0. This is 0 because it's resting. It's at rest over here. The height is 0. So potential energy is 0 here because this is the resting stage when it's resting here. And then the kinetic energy at this level will be maximum. That's why it must move fast at this point. Now, here, because you move with this is the height. From here to there, this is the height. Move it through this height. So because of the height, it has potential energy maximum here. The same thing if you are here, this is max. Kinetic energy here will be 0 because it's like just at rest before you release it. Ke will be equal to 0 when it's resting before you release it. Okay. So as it moves in between, if it's in between here, in between the height and then the highest height and then the resting point, then you have both potential plus kinetic in between when it's in between. Height and then the resting point. Okay. So you can get this question in these 2 different ways, either the pendulum or the height problem. Okay. So with that, let's go to number 14. So number 14 says that a ball rolls down an incline, passing through the 4 positions shown in the diagram. So you have A, B, C, and D, right? A, B, C, D. It said, in which of these positions does the ball have the maximum kinetic energy? Maximum kinetic energy. So which one are you choosing here? A, B, C, D. Maximum kinetic energy.
C.
C. You are right. C. Yeah. So C is like the one that we're talking about, like the one here. So this is like the A, B, C, and then the D is somewhere here. Okay. Got the D because of the height above the ground, it has both potential and kinetic at that point. So C is correct. Maximum kinetic energy, correct. Yeah. Great. All right, let's look at another experiment problem, page 222. 222. Long paragraph, but the answer is in the question. So take about 1 minute to look at question, to read the question, 23. 222, number 23, 24, 25. That's what we're looking at. All right, so it says that a chemical test for the presence of dissolved vitamin C is that the vitamin C bleaches a dark blue solution of indole phenol. A student placed 1 ml of indole phenol in each 6 test tubes, different test tubes. The student added a different liquid, drop by drop, to each test tube until the blue color of the indole phenol disappeared. As indicated in the following table, each liquid took a different number of drops to bleach out the blue color of the indole phenol. So you have the liquid, and then they gave you the number of drops. Lemon juice, you need 5 drops. Fresh orange juice, 20 drops. Cooked orange juice, 30. Pineapple juice, 30 drops. Apple juice, 45 drops. Water, 100 drops, but did not bleach. And 23 says that which liquid had the highest concentration of vitamin C? A, fresh orange juice. B, water. C, lemon juice. And then D, pineapple juice. So which one has the highest concentration of vitamin C?
Lemon juice?
Lemon juice. Yes, lemon juice. Why do you say lemon juice?
Because it requires only 5 drops.
Yeah, so you just need 5 drops and then it changes the color. So it means that it's very concentrated. You know, think about like the soap Tide. You know, Tide is so concentrated compared to other liquid soap. So use small amount of it, it does more cleansing than the other ones. You know, yeah. So lemon juice has a lot of vitamin C. So just few drops changes it quickly. Correct. Yeah. Then 24. It says, according to these results, when orange juice is heated, its concentration of vitamin C is A, increased, B, reduced, C, destroyed, and D, maintain at same level. So what happened to me?
Reduced.
It's reduced. And why do you say reduced?
Because
Your reason?
it's less. I mean,
It says less. Okay, let's go back. Okay, it's reduced. That's correct. Yeah. So if you look at when it was not cooked, fresh orange juice, you have 20 drops, right? And then when you cook it, you need 30 drops. You need more drops before it can bleach, right? So it means that the concentration of vitamin C went down. You know, don't have too much of that in there.
yeah.
Because the drops, you need more drops before you have a change. Okay, so it's reduced. Okay. All right, correct. And then 25. Which of the following substances contain no vitamin C when the study began? No vitamin C. The indole phenol solution, the cooked orange juice, lemon juice, and then the apple juice. So no vitamin C. Which one? Anybody?
Would it be A, the indole phenol solution?
Yes, it's A, the indole phenol solution, because that is the indicator, what you're going to use to measure or detect, what you're going to use to detect the presence of vitamin C. So it shouldn't contain vitamin C to begin with. All right, great. So that's correct. So you see, questions like this, it may look long, in the passages of the experiment may look long, but don't skip them. The answers are always in there. You know, so I always encourage people, make sure you don't skip these type of questions. You don't have to have any knowledge. The answers are always in there. Okay, good. Something like 26. 26, nobody should get that wrong, right? 26, like 26, it's a diagram. It's a bonus question to me, you know. It's a which shadow is the longest? Looking at the diagram. So which shadow is the longest? If you're not too sure, put your paper or pen to do, you know, to measure and see, line them up.
You can see it.
You see?
Oh, I said you can just see it by looking at it, which one is the longest.
Yeah. Mm-hmm. So that's a bonus question to me. Yeah, I would say it's a bonus. If we can't see this one, then that's a big problem. Yeah, I see it. Then either you got to check your eyes and see if there's a problem or something.
Right.
It's a giveaway to me. But I'm sure they know people get it wrong, so they put these types in there.
Yeah, they probably put it in there because enough people got it wrong. You're right.
Exactly right. So to be careful, you can take a pen or pencil and then horizontally see if they line up, you know. Okay, good. Yes, we did the diagram on page 22 to 3 already. There. That's the hormone endocrine system, so we'll skip that one. Let's see. Okay, another diagram, page 224. Page 224. Number 36 to 38 is based on the diagram on page 224. So take a minute to look at that. So the testing on the diagram. Again, you have to be careful with this diagram. Careful. Okay, let's look at 36. It says, at which point is the population growth most rapid? Most rapid. So to answer this question, think about slopes. Your idea of slopes should come to your mind. Most rapid. The first person, I didn't hear you well. What do you say?
B.
You said B. Okay, let's see.
C.
Okay, somebody says C. Yeah, it's between B and C. Between B and C, all right? But then, if you look at it carefully, which one has a steep, has the greatest slope?
Well, 1 and 2 are carrying the capacity of the environment.
So
it's not necessarily addressing the population.
Okay, so we eliminated 1 and 4, we eliminated that, right? So it's between B and C. Most rapid, right? So, but think about slope. Which one has the greater slope? Which one has a greater slope? 2 or 3? That's why you have to be careful. 2 or 3?
3.
Look at it again. 2 is steeper than
Oh, I see.
3. Do you all notice that? 2 is a little bit more vertical than 3. So the rapid rise is the steepest one, which is 2. It's rising up faster, like, you know. So the answer should be B, 2.
Okay.
Yes, you know.
So what's the difference between the actual population in the question, because they're talking about population growth, and the capacity of the environment? Because that's what the little straight line is. Isn't that correct?
Yes, but the if you look at the dotted line, it begins like it all begins with the from 1, 2, and then becomes 3 and 4.
Right.
Yes, it's part of it. Like 1, 2, and then that's the actual population what it should be, but then it deviates. The current capacity is the deviation from the actual, where it becomes flat. So you can say that the current capacity is 1 and 2, and then the flat part.
I see.
Yes.
So
that's how
then
it
2
deviates.
is the answer when it increases the most. When
Yes,
it connects to 3.
it's 2.
Okay.
Yeah. So
All
2
right.
is like steeper
Okay.
I
than
see.
3. Yes.
Got it.
Yeah, okay.
Thank you.
You're welcome. Yeah. Then 37 says, at which point is there a decrease in population due to competition for dwindling food supply? So now the population is going down. So if going down, you think of negative slope. It's decreasing, like there's acceleration, accelerating, and deceleration, those type of things. Here we did the graph slopes. That's what they're trying to test you here. So where is there a decrease in population? 1, 2, 3, 4. Which one?
4.
4. Yeah, if you look at 4, it's declining. Negative slope is going down. So 4. And then 38 says that for which type of organism is this graph believed to be typical? Believed to be typical. A, bacteria only. B, plants only. C, all animals except humans. D, all organisms, including humans. So which one do you believe is typical?
D, all organisms.
Yes, all organisms, including all humans. Right? This is going to happen to any population at all. Based on condition that there's no food is coming in. And that's a condition. If you don't bring in any extra food, then beginning when we have, let's say, a few pure organisms, they'll multiply fast, feeding and multiplying fast. Now, I guess your point, when they produce enough offspring, the food won't be enough. So the food is no more enough in the population, then they begin to grow, reproduction slows down and they begin to die off, So it can happen to any organism at all, We don't see it, let's say, in the human population because we're always replenishing the food that comes in. So that's why we don't really see much of this. But if you block out food, then it will survival of the fittest, Yeah, so people will die off. Right? All right, so that's correct, D. Okay. All right, let's try a quick review. 39 for a quick review. Which of these nitrogenous bases may be found in RNA but not DNA? Uracil, adenine, thymine, guanine. Let's test ourselves for past knowledge.
A, uracil.
Uracil, correct. So uracil in RNA but not in DNA. Perfect. All right, number 40. A substance with pH of 8 is pH of 8. We did that last week. Strong acid, weak acid, strong base, weak base.
Base.
It's a weak base, correct. Weak base. Let's look at 41, sorry. 41, we didn't talk about that, but we can do that. Binary fission. Binary fission means that splitting into 2, right? Organism splits into 2. It's in paramecium and budding in yeast cells are examples of. So budding is just shoot, it's an offshoot of itself. Asexual reproduction only, sexual reproduction only, spontaneous generation and sexual reproduction, and D, both sexual and asexual reproduction. Binary fission and budding.
Yeah, can you write down the
The options?
put this on. Did you say the answer?
I would say A.
I gotta go pee.
You said which one?
The answer.
What's the answer here?
Just circle it. I gotta pee.
What's the answer?
A.
A. Yeah. So it's asexual reproduction. Okay, asexual, binary fission. So the organism just splits into, so one organism splitting up. It doesn't involve like a male part and female parts. All right. So it's A. It's A. Good. We did 42 last time. Okay. So let's look at 43 and 44. So read the experiments and then answer 43 and 44. Again, the answer is in the question.
Come.
They say a student was testing the colored materials in spinach. He ground up some spinach leaves in acetone. He then filtered the mixture and obtained a dark green filtrate. He placed a spot of this filtrate on spot X on a strip of filter paper. Then he hung the dried paper in a tube containing a mixture of petroleum ether and acetone at the bottom. After a while, he observed moisture creeping up on the paper and several bands of yellow and green color. For the three, so this experiment uses the technique of A, fluorescence, B, photosynthesis, C, centrifugation, and D, chromatography. So what do you think here? Fluorescence, photosynthesis, centrifugation, chromatography.
I'm gonna guess it's D, chromatography.
You are right. And why do you think, why that guess?
Because he was testing on colored materials.
Perfect. That's what I want to hear. Chroma. Chroma means color.
Mm-hmm.
Root of words, color. And if you get a question, you talk about color, you know. So this experiment is what we call chromatography. Correct. So in chromatography, this is what is happening. Okay. Let's go on. My pen froze a little bit again. Today the pen is giving me issues. Okay, so basically, chromatography, you put the drop on the paper and then put it in the fluid, like you set it, a strip of paper or filter paper in the solution. Okay. And then the solution rises up the filter paper and it separates the content based on the weight, the molecular weight. So the heavier one will travel slowly, whilst the lighter material will move faster. So it helps separating them on the paper. Okay. And then you spray it with a chemical that can give them different colors. Okay. So that's a chromatography study. All right. And then number 44. It said the student should conclude that spinach contains two kinds of, sorry, it said the student should conclude that A, so here I'm making conclusion. Remember, I said they'll test on some conclusions. So what conclusion can we make here? A, spinach contains two kinds of chlorophyll, green and yellow. B, spinach contains more than one kind of pigment. C, all organic pigments are soluble in acetone and petroleum ether. And D, all organic pigments migrate on filter paper at the same rate. So what conclusion can you draw here? And the answer is in the question. Any conclusions?
B.
Which one?
B, spinach contains more than one kind of pigment.
Yes, spinach contains more than one kind of pigment, correct? But what leads you to that particular answer in the question, in the experiment? What leads you to that?
I read the question again, and it shows that when he put the chemicals in all together on the paper, it just started absorbing, the paper started absorbing the mixture, and the colors that were released were green and yellow.
All right, so those were two colors, but again, you said B, right? More
It
than
has
one.
several bands of yellow, so it could have been dark yellows or light yellows.
Perfect. So that's the key. The key here is the last sentence. After a while, he observed moisture creeping up on the paper and several bands of yellow and green color. So that's a statement that tells us that it's more than one kind of pigment. So you cannot
Could have
just.
been right. It could have been more than one shade of yellow.
Exactly. So A, that's why A cannot be correct. You cannot say it's two kinds. But it's more than. That's all we can say. So that's the conclusion you can draw from this experiment. You know. So as I said, the answers are in the question. You just have to read it carefully. You know. Okay. All right. So that's good. Maybe one more problem here. Page 229. Page 229. If you go to page 229, the same thing. Number 4, we just discussed that. It's in different form. Number 4, 229, number 4. The tiny projections in the small intestine adapted for absorption are called. So now just backwards. Villi, right? The villi, that's what we did. You know. They asked in different form again. Okay. Page 232. 232. Let's look at number 13. Most of the work done by the human kidney occurs in the A, nephron, B, neuron, C, ureter, and then D, alveolus. So it's asking you basic unit, functional unit. Yeah, nephron, correct. The nephron. That's where the urine is produced. Okay. All right. Let's look at number 14. What do you think from 14? Try that. It's almost like a math problem. All right, so what do you get for number 14?
8. B.
8, correct. All right, so 20 washers, 10 bolts. So the ratio is 2 to 1. For every 2 washer, you have 1 bolt, right? That's what that means, 2 to 1. So if you add 4 bolts to one side, that means you have to add twice that amount of washers. So 8, that's correct. I hope everybody got that right. Okay. All right, good. Number 15. From chemistry, compounds with different molecular structures by the same formula are called A, isomers, B, isobars, C, isotopes, and D, isotherms. Same chemical formula but different structures. What do you call them? Molecular structures.
A.
Yes, isomers. Isomers. Yeah, isomers. Number 16, another experiment. Look at 16. So testing you about control. A student wanted to test the effect of different sugars on growth of a certain mold. The sugars to be tested were glucose, fructose, and sucrose. 1 gram of each sugar was placed in a tube of 10 ml of water, and a bit of the mold was put in each of the 3 solutions. To add a control to the experiment, the student should also have A, made 2 setups of each of the 3 sugars. B, tested ribose and galactose. C, made 1 setup of just water and mold. And then D, kept the 3 setups in the light. So what should be the control for this? C, yeah. So setup made us 1 setup of just water and mold. All right, so you eliminate what you want to test, from it. So the sugar should be out, okay, to get a control. So control experiment, correct. All right, number 18. Number 18, again, you want to make hypothesis from this experiment. 18. All right, so it says undisturbed layers of rock were examined. You have mammal followed by fish, then bird fossils were found only in the upper layers. Fish were in the layers beneath those, and neither fish, birds, nor mammals were in the deepest layers. This would tend to support the hypothesis that A, vertebrates always coexisted with invertebrates. B, fish were the first vertebrates to evolve. C, all vertebrates evolved at about the same time. And then D, birds evolved from fish. So based on observation, what hypothesis can be made here? So different layers, fish in the lower layer, and then
B. I'm guessing.
this say B or D?
B.
B, as in boy. Yeah, it's correct. B. So fish were the first vertebrates to evolve. That is what is, in other words, if you look at what they're saying, the fish came and they died off, then the other one came, like lived on top of the other, something like that. They died off, and followed by other layers, So that archaeologists, that's what they do. Look at the rocks and then they look at what is beneath and say, okay, this one came first before that, and so on. So that's hypothesis that they make. Great. So I believe you've seen a couple of ways in which experiments are asked. either you make conclusions, inferences, and so on. Okay. Let's make one more experiment conclusion, and then we'll take a quick break and come back to do some math, as I promised. All right. So the last one for the science record, question 26 and 27 on page 235. Page 235. Again, the answer is in the question. 235. So 26, all right, so it says, in which of the following do men expend energy most rapidly? Most rapidly. So for men, so it says light physical work, working outdoors, limited walking, and bench work. So for the men, most rapid. So which one do the men expend most energy?
Walking outdoors, B.
Working outdoors, let's say working outdoors. The rate is 3 for working outdoors.
Oh.
You have 3 calories per minute.
The answer is A, light physical work.
Light physical work, yes, light physical work, because it's 4.5. So light physical work, yes. So that's correct. Okay. And then 27. Based on the data, which conclusion can be drawn? Now you want to make conclusion. So we're going to study the two. The number of calories used by men and women are most similar for purposeful working activities. So if we look at purposeful working activities, most similar. Okay. Then B, men use calories as rapidly sitting as women do working outdoors. And then C, women use calories more quickly than men do when driving a car. And then D, women burn calories more slowly than men do in all activities listed. So conclusion.
It's B, men use calories rapidly sitting as women do walking.
B.
They burn the equal amount of calories, 540.
Yes, but we want to look at the overall. So the conclusions are looking at the entire picture. What is happening? Say it again. If you look at what's happening, you can look at both data. Compare the rates.
D.
D, yeah, D is more appropriate, right? Women burn calories more slowly than the men do in all the activities listed. You can, if you look at the data, the numbers for the men is higher than that for the women throughout. So the conclusion is based on the overall picture that you notice. So it's D.
Okay.
It's D. Yeah. All right, great. So I believe at least we know how to answer some few questions on experiments and so on. Okay. So the idea is when you see these problems, don't skip them. Take your time really carefully. You don't have to have any knowledge of what they're asking you. You just have to think about the question, what they give to you, and analyze it. You know, so don't get scared when you see those problems. They're ones that can easily score. Okay. All right. There are more experiments that we can talk about, but for the sake of time, if you get a chance, go through yourself. You know, some based on the syllabus that I made. You know, the numbers. You should be able to go through the numbers on the last column for today's lesson and get them right. Okay. All right. So, as I promised, let's take 5 minutes break, and then we'll come back and work on some math problems. So let's take 5 minutes and come back. It's 11:45, so 11:50. Come back and let's continue. All right, so it's 11:52. So I think we can start. All right, so I believe last time we've stopped on number 24. So we'll continue from 25. We'll try to finish up this particular one. All right, so take about 5 minutes to work on 25 to 29. 25 to 29.
I'm sorry, what page is that?
Oh, sorry, let's see. The first math test. It's on page 129.
Okay.
No, hold on. I think I got it wrong. The first math.
108.
Page 108.
Yes, 108. Right.
What examples are we doing?
25 to 29.
Oh, okay. Thank you.
All right.
Inachomo utachomeka. Acha. Stop. What's the mouse?
If you could mute yourself, if you have like kids around, so that it doesn't come in. I'm recording it, so. All right, let's come back and look at number 25 first. So for 25, say 2/5 of 1%, 2/5 of 1%. So if I'm doing this question, I'm going to write this as 2/5 of 1%. That means multiplication of its multiplication, and it's 1%. 1% is 1 out of 100. So you want 2/5 of 1 out of 100. Okay. Now, when I look at the answers, the answer is in decimal. So since it's in decimal, a quick way to do this will be to change, if I change this to decimal, 2 or 5 to decimal, I'll get 0.4 in terms of decimal. So it's like it's having 0.4 times 1 over 100. And I know this will be the same if I multiply horizontally. It's 0.4 over 100. That's what this means. 0.4 over 100. So what's 0.4 over 100? This is the same as saying I have 0.4%. So that's what this means. 0.4%. If I have 1 over 100, it's 1%. If I have 2 over 100, it's 2%, and so on. So I have 0.4 over 100, it's 100%. So that's how I will do it quickly. I'll change this to decimal, and I know it's over 100. That's why I kept 100. Anything over 100 is easy to play around with it. Okay, 0.4%. Well, 0.4 over 100 means 0.4%. Okay. If you have any number on change percentage, you multiply by 100, and you get a percentage. Okay. So the answer should be 0.4 D. I hope everybody had that. Don't be tempted to choose A or C. Okay. Okay. Well, 26 should be a little bit more straightforward. What do you get for 26? You have a child dose is equal to
I got
y
8.
over y plus 12, right? Then they gave you y is the age of the child. So we have 8. So this will be 8 over 8 plus 12 times, I left something out here, say times adult dose. So we multiply this by the adult dose, and adult dose gives 10 milligrams. Okay. So order of operation, you have to work this out first. So 8 over 20, then times 30. Okay. If you want to make any errors, you can put a 30 over 1. You know, like this. And then with your calculator, you can multiply 8 by 30 and divide by 20 times 1. Or if you're somebody who likes to reduce, then you can reduce the lowest terms. I can cross out zeros. 2 into itself is 1, 2 here is 4. Then I can have 4 times 3, which is 12 milligrams. So you can cross out, or just multiply horizontally and then divide whatever you get with your calculator. Okay. Then number 27. So which of the following problems is the value of 2 over 3 change by the calculation change? Yeah. So if you look at A, 2 over 3 plus 0 is the same thing, doesn't change. Same 2 over 3. Then the other one is 2/3 divided by 1. If you divide any number by 1, the number doesn't change. Same number. And then for C, you have 2/3 times 3/3. 2/3 times 3/3. 3/3 is the same as 1. So 1 times any number is the same number. It doesn't change. So it means that the one that will change is D, which you have 2/3 divided by 2/3. If you're dividing two fractions, you keep the first fraction, take reciprocal of the second fraction, multiply 3/2. Okay, so if you do this, this will cross out. You have 1, 1, 1. So you have 1. So this changes from the previous fraction. So D is the answer for that one. Okay. And then for number 28, for 28, you have, it's a two short sides of a right triangle are 12 inches and 9 inches. How long is their side? No. For this question, we have to remember this fact, the Pythagorean Theorem. Pythagorean Theorem. Okay. So for a Pythagorean Theorem says that if you have a right angle triangle, let's call this A, this B, and then the hypotenuse C, the long side is hypotenuse, right? C. It said that the square of the short leg, got the short leg and long leg. If you square one of the short legs plus the square of the long leg is equal to the square of the hypotenuse. This is Pythagorean theorem. Always true for right angle triangles. Okay. So for this question, what we have here, the two short sides are 12 and 9. So if you have 12 and 9, 12 and 9, you want to find the long side. Yeah. So A is given, so A squared plus B squared, which is 9, all this should be equal to C squared, the long side squared. Twelve squared is 144 plus 9 squared is 36. So if we add this, no, 9 squared is 81. What am I writing? This is 9 squared is 81 here. So this is 81. So if you add this, you should get 225. 225. Okay. So C squared is equal to 225. So this is C squared. Okay, so C squared here. C squared. So we have 225 is equal to C squared. So to get C, you take square root of both sides. So take square root of that. So your C will be equal to 15. 15. Okay. So it's 15 inches. So this is a Pythagorean theorem. Pythagorean theorem for this question. Okay. Right. So number 29. So number 29, this is where you have to do some conversions. Okay. So suppose that you have 3/4 parts of blood. So 3/4 parts of blood have been donated for blood transfusion, and 2/3 pints have been used. How many pints are left, right? So what you have is 3/4 quarts. Okay, quarts. But the amount used is 2/3 pints. You have two different units, quarts and pints. You can't work with them together. You have to work with the same units. So that means that you have to convert one to the other. It's very important to have the same units to work with. So what we could do is to change this to pints. Okay, then we can work with that. So quickly, we have to decide on how many quarts you have in a pint or how many pints you have in a quart. Okay, so you have to do the conversion. So you have to remember that you have two pints is equal to 1 quart. This is a conversion that you have to think about. 2 pints is 1 quart. Right. So to convert 3/4 to pints, so the first step is to convert. So let's call this step A. It means that we have to multiply 3/4 by 2 so that we can get the answer in pints. Okay. So this is testing us on multiplication of fractions. So that means that I have to convert this, change this to improper fraction. So 4 times 3 is 12 okay, plus 3. So that'll be 15/4 times 2. All right. So that gives us, we can put this over 1. So this would give me, divide by, that's 15/2. I can reduce the lowest term. This is 1. This will be 2. So 15/2. Okay, which is the same as 1, that's 7 whole number, 1 out of 2. So 7.5. 7.5 pints. So that's what you have. Okay. But the question says this is what was used. This was used. So it means that I have to subtract. So step 2, you have to do 7.5 what you have minus what was used, which is 2/3. Okay. So what was used. So quickly, I can create a fraction from this. Or let's first start with the LCD. So the LCD here will be 4. So this will be the same as writing 7 LCD of 4 multiplied by 2 to get 4. So this times 2 minus 2/3. Okay. So since this is a smaller fraction, I can create a big fraction out of this. So I borrow 1 from 7. So I have 6 whole numbers left. The one that I borrowed is in terms of the denominator, which is 4 out of 4. So I add the 4 to this 2, so it can 6/4 minus 2/3. Now I can subtract. 6 minus 2 is 4. 6 minus 3 is 3 over the common denominator 3/4. So the answer will be 4/3 pints. That's how much left. So this involves conversion and multiplication and subtraction. 3 things in this question. So anybody has a question on this, take 30 seconds to look at this. If you have a question, you can let me know. All right, so we are all fine with this. All right.
I'm good.
Okay, so let's go on to the next page, 109. Let's try 30 to 35. 30 to 35. So let's take like about another 5 minutes to look at those questions and I will discuss. I believe for number 30, that should be straightforward. It means which number multiplied by itself 3 times will give you 216. So you can work backwards, right? Take the number multiply backwards or just take the cube root. Yeah. So which number multiplied by itself 3 times will give you 216.
B.
B, yeah. So this is B. X is equal to 6. 6 times 6 times 6 times 6 gives you 216. So you can work backwards here. All right. Number 31.
C.
C. Okay. All right. So here, if you're stuck, you can use the percent proportion that I showed you here if you are stuck with this question. So say what percent of 180 is 225? What percent of So if you think of part and whole, part over the base is equal to the percent over 100. That can help you answer this question if you're stuck. So we said that here is a what percent off. So when the percent is missing, you know the part is associated with the word is. So it's 225 off the base, which is 180, should be equal to x out of 100. Okay, so this would be a percent proportion. Okay. So if you do the cross product, 180x is equal to 225 times 100 and divide by 180. And then you should get 1225%. Correct. So think of percent proportion all the time. That can help you a lot. Okay. All right, what about 32? In a survey of community needs, 380 of 1900 respondents said they wanted purer water. So we have 380 out of 1900. They wanted purer water. Okay. They say what percent did not request pure water? So 91 did not. So there are two ways you can do this problem, to get did not. So the first way would be to find how many people did not want. So not want the pure water.
80%.
Okay. So we can subtract first, right? You can do a subtraction here. So it means that 1900 minus 380, then you get those who did not want the purer water. So that's one approach. Okay, so 1900 minus the 380. So you get 1520 who did not want. So what is the percentage? Percentage who did not want. So that will be equal to, you take those who don't want over the base or the whole. The total is 1900 out of 1900, and then multiply by 100, and then that should give us those who did not want. Okay. So that's 80% did not want. Okay, so that's the key here. So that's one method. The other method will be to find the percentage first of those who wanted and then subtract from 100. That would be your method number 2. If some people did it that way, that's correct too. Method 2. So method 2, you can do 380 out of 1900, multiply by 100 to get a percentage, the fraction that's wanted. So this will give you 20%. Means 20% of the people, they wanted the purer water. So to find the percent that did not want, percent that did not. Then you know the 100% is the whole. When we work in percentage, 100% is the whole. So if you take this 20% out of 100, then it means that you have 80% who did not want. We come up with the same answer. So two approaches. Either work the percentage, find the percentage first and subtract from 100, or subtract to find the number of people and then find the percentage that did not want. Two ways. Okay. All right. Any question on this particular one?
No.
All right. 33 should be straightforward. I believe that one should be straightforward for us. So let's do that quickly and we'll look at 34. 33. So 3 over 4 off is multiplication. So change to multiplication times 1 over 2 plus 1 over 4. Okay. So order of operation, we have to do the grouping first. So what do you have in the parentheses? You have to work this out. So since you are working with two fractions, you're adding, we need to find the LCD. So LCD is 4. So this is times 2 to get 4. So multiply the numerator also by 2. So it's 2 out of 4. This remains the same since it's times 1 times 1. Add the numerators. So 3 over 4 times. So this will be 2 plus 1, which is 3, over the common denominator, which is 4. Okay. So 3 over 4 times 3 over 4. Now we multiply horizontally. 3 times 3, which is 9, over 4 times 4, which is 16. So you should get 9 over 16, which is C. Okay. So 34. 34 will be something new for most people. So let's look at that one. Now 34 is what we call similar objects, similar object type of problems. All right. So let's do a little review of that. Similar shapes. Geometric shapes. Okay. All right, let's begin with a rectangle. So if I have a rectangle, that's a small rectangle, and then a big one. If this side is A, the length is A and B. Let's say the length is C and D. If they are similar, then the ratio of the corresponding sides will be the same. Similar objects, ratio of corresponding side will be the same. So if I take the ratio of D to A or A to D, whichever one, have to be consistent. So let's say ratio of small side, ratio of the length to the width should be the same. Ratio of length should be equal to the ratio of the width. The ratios. So if I say the ratio of A to the short length to the long length D should be the same as ratio of the short length here, or short width, which is B, over C. They should be the same if I compare the ratios. Or I can do the other way around. I can say that the ratio of the length to the width, I can also do that. So ratio of length to the width. A to B should be the same as the ratio of D to C. You just have to be consistent. Okay, consistency, that's all. Okay, so ratio here, ratio of the length. So if I say the length over, let's say the width, should be the same as the length of the other one to the width. It is the small, it's a small, and that's a big. Okay. Just have to be consistent. Okay. The same with triangles. If you have triangles, the same thing happens with a triangle. Let's say this is A, let's call this B, and maybe C. And I have a bigger form of the same corresponding, like the same triangle, similar one, but bigger form of that. if they're similar, so if this is D, E, and F, then the ratio of A to D, the corresponding sites A to D, should be the same as ratio of B to F, B to F, and this is the same as the ratio of C to E. Okay. They should be the same. So you can use the proportion to solve the missing side. Okay. So for this question, what I have in this question, you have a rectangle. This is the first one is of 12 and 8. So the length is 12, the width is 8. And then you have another rectangle, similar rectangle, and they said this time the length is 15. So this length is 15 centimeters. They want to find the width. So let's call the X missing. So I can do the ratio of the small width, the width of a small rectangle to the width of the bigger one should be the same as the ratio of the small length of the small to the length of the big one. I can set that proportion like this. Okay. And then we can solve the proportion. So we solve this proportion, you have 12x. It's equal to 8 times 15. And I can divide by 12, divide by 12, and then you get the answer. So you have x to be equal to 8 times 15 over 12. You can use a calculator, 8 times 15 and divide by 12. Or if you like to reduce like me, then you can also reduce the lowest terms and then get the answer. Okay. Now you're allowed to use calculator to maximize the use of it. So 8 times 12, 8 times 15 divided by 12, and then you should get, yeah. So you should get 10 centimeters. Okay. So that'll be B. So that's how you deal with similar objects. They can give you in a triangle form, or they can give you in terms of like a rectangle. Compare the ratios, length to width, length to width. All right, width. Now, what about 35? What do you get for 35? That one I believe should be straightforward. Anybody for 35? See, a certain drug consists of 2% of a solution.
D.
Say it again. I didn't hear what you said. Can you repeat?
D.
D. Okay. All right. So you have 2% of solution, right? That's given. So you can use a percent proportion here. 2%. So the percentage 2% that is given, then determine the part and whole. If there are 30 ml of the drug available, so you have 20. It means that 2% is 2 of the medication out of the solution, 100. So the 2 will correspond to the 30. That's the amount of drug. You have 2 milligrams of the drug in 100 solution. So it means the 30 should go here, 30 ml. That's the amount of medication I have. And then you want to find the solution. So we don't know. So 30 out of the unknown, the solution. So that'll be your percent proportion. And then you can do the cross product. So X is equal to 30 times 100. And then you can divide by 2. So X will be equal to 300 divided by, so 3000 divided by 2. And then that gives us 1500. So that's correct. 1500. Perfect. Great. All right. So let's try 36 to 40. 36 to 40. Okay. So for 36, you want to find H. You want to find H. Okay. Would somebody like to talk us through this problem? You want to test your skills? Any volunteer to talk us through this problem?
Which question?
36.
I got A.
You did A. Okay. What do you do?
First of all, I wait. I multiply 2, so I get rid of half.
The fraction. Okay.
Yeah, and then I divide it by B1 plus B2.
All right. So first you say you multiplied. So let me go step by step. So we have a fraction. You want to get rid of fraction by multiplying by reciprocal, right? So what she's saying is that you multiply both sides by 2 over 1, or just 2. So multiply the left side by 2, and then multiply the right side also by 2 to get rid of fraction. So that's what she's saying. So I can do 2 over 1. Okay, so this will cross out. So you just have H times B1 plus B2 is equal to 2A. Correct. Okay, so we've gotten rid of the fraction. So first, get rid of the fraction. Get rid of fraction. Okay, multiply by reciprocal. Okay, all right. So at this step, now you have H times B1 plus B2. So the H is multiplying. So now you want to undo the multiplication to get H by itself. So this is the time, as you said, you have to divide. So you have to divide the left side, the right side by B1 plus B2. Whatever you do to the left side of any equation, do the same thing to the right side. B1 plus B2. So you divide both sides by the same factor. So we can get rid of this. This will cross out since they're the same. The whole thing crosses out. So we'll be left with just 2A over B1 plus B2. And that is your H. So this is your answer. So 2A over B1 plus B2. So that's why A is correct. A is correct. Great. Good. Now let me throw in one question here. What if the question said find, so the same thing, I'll make up a problem. So the same thing, have A is equal to 1/2 H, B1 plus B2. Now this time we'll say find B1. We want to find B1. Okay. So to do this, we can do the same thing. Get rid of fraction first. So multiply both sides by 2 to get rid of fraction. 2 times 1 over 2H. So we can do 2 over 1, so that this will cross out. So you have 2A is equal to H times B1 plus B2. All right. Then we can get rid of the H. So B1 is hiding. So we can get rid of the H by dividing both sides by H. It's multiplying, so you're undoing the process. So I divide by H, divide the left side by H. So this H will cross out. So you have 2A over H is equal to B1 plus B2. So now you've gotten rid of parentheses. Okay, so just have B1 plus B2 left. How can I get B1 by itself? This time the B1 is adding on, it's addition. So you have to undo the addition by subtracting. So I take out B1 from the left side, take out B1 from the right side. In other words, you try to move. Sorry, I take out B2 from this side and the left side. So if you do that, you have B2A over H minus B2 will be equal to B1. Okay. So that will be the answer if you want to get B1 by itself. Okay. So practice on how to get variables by themselves, all right? You know, how to get variables by themselves, called literal equations, solving literal equations. Okay. Equations that have the sort of variables. Okay. That's what we call it. Okay. Great. Any questions on that one? I hope you should be able to do it. Okay. All right. So what are 37? 37 again, proportion. I'd like to know how you do 37. Okay, you have to read it carefully. So medication has 3 parts of a drug A to 7 parts of B. 3 parts A to B. 7 parts B. Okay. So this one, think of a diagram. You have A and B. This is 3 parts, and this is 7 parts. Okay. Then you have a total of 420 ml. That's the medication, how much you have. And the question says, how much ml do you have here? Okay. So how do you think I should approach this question? You can use proportion, but you have to be careful with the numbers that you use. Anybody wants to try that one? Let me help out here.
From the proportion?
Yeah, you can use proportion for this. So what should I set up?
We have to multiply 420 milliliters times 3, I think.
Okay. All right, before you go, what proportion? What should I write down? The proportion. The proportion I have to set up. Okay, let me help out here. All right, so if you have this question, right, you have to do the total parts here. Very important to use the total parts. Total number of parts. And the total number of parts here is 10. 3 parts to 7 parts. So I have a total of 10, right? So for the A, we're looking for A. So we say that 3 parts of A, so 3 parts of A over 10 total parts. That's what we have so far. Now, the 10 parts is equivalent to the 420. So that's the 420 here. That goes here, 420 ml. It goes with this. And then the A, we don't know how many ml. So that's X. That should be here. Yes. So this should be your setup. 3 out of 10 should be the same as the ml that you have of A, ml of A to ml total. Okay. They should match like this. 3 out of 10, this to that. Okay. So when they give you the total volume, use the total parts. That's the catch here. Yeah. So now we can solve 10 times x is equal to 3 by 420, and then divide by 10, divide by 10. So x will be 3 times, that will be 126. So it's 126 ml. Okay. So remember to the total part if the question looks like this. Yeah. I mean, the question can come in another form where they give you A, you know A and B, you don't know the total. If you don't know the total part, then you can just put the ratio. 7, let's say 3 to 7 will be equal to whatever they give you. Let's say the volume of A to for X for B. And they can set up the other way if you're comparing the two. But the reason why we're using this is because they give the total volume. So we have total volume, a combination of this means you have to use the total number of parts. That is what we should be doing here. Okay. So be careful with this type of problem. Okay. What are 38? 38 is algebra. I want to simplify this. So what do you think I should do for this question? Any volunteer for this question? What should I do? Okay. Do you have any common factor here? So if you look at the numerator, you have a common factor, a squared minus a. Common factor is a. So you have to factor out the a. So if I factor a out, this will be a here, then minus b over, there's a common factor in the denominator, which is b. So factor out b. So factor b out, you have b minus a. All right, so factor. Okay. Now, before I can cross anything out, they have to look alike. How can I make this look alike? I have a minus b. I have b minus a here. I can make them look alike by flipping the position of one of them. Okay. So remember, if I have 2 minus 3, this is the same as writing 3 minus 2. I can switch the 2 positions and then take a negative of that. They're the same if I change the positions. All right. Likewise, if I have a minus b, this is the same as I can switch the position and write b minus a, but then I have to take the opposite of that. Then they'll be the same. So I can do the same thing here. I can switch a and b. So I write b minus a. Now I have to take the opposite, negative of this. So negative of this, and then this is a. I can put it in front like this. So negative of all this will be the same as that. Then this is b over b minus a. Now this and that look alike, b minus a, b minus a. I can now cross all this out. So I end up with negative a over b as the answer. Okay. So in subtraction, if you switch the positions of the numbers, you have to take the opposite of the numbers for it to be the same. Okay. So factor out first and cross out common factors. Now for 39, that one will be good to summarize in the diagram form. It says a rectangular room A has an area of 400 feet. So rectangular room, so draw a rectangle, diagram form. Let's call the width and length. The area here is 400 feet squared. Then there's a similar rectangle. So let's draw that. The side is say half as long as room A, half as long. So it means that the width here is 1/2 of W, and this is 1/2 of L, based on information. We want to find the area. The area here is, we don't know, so question mark. So how do you find the area of a rectangle? The area of a rectangle is length times width. So the area here will be the length times the width. And this is given as 400. So I have 400 is equal to the length times width here for the first, the big one. What will be the area of the small rectangle here? The area of the small rectangle will be A is equal to the length is 1/2 times the width, which is 1/2. So if I multiply this out, I'll get 1/4 length times width. That will be the area. So the area here is 1/4 length times the width. So how do I find the area here? Now, the length and the width, if I look here, this is the same as what is given. Length times width here is 400. So I can put a 400 in place of the length times width, because that's what is equal to the area of the big rectangle. Okay, so the area here will be equal to 1/4 times the length times width, which is 400. So if I multiply this out, I'll get 100. So the answer is 100 feet squared. That's the area of the small one. 100 feet squared. So if you summarize in a diagram form like this, it will help to make your life a lot easier. Any questions on this one? Everybody okay with this particular one? The algebra parts?
Yes, thank you.
Good. Okay. Good. All right. Yep. And then number 40, I think number 40 should be a little easy for you now. Combined with 480 of water, always good to summarize in diagram. So if you use diagram, it helps you a lot. Combined with 480 of water are 120 ml of alcohol. So it means that you have 480 ml water. And then the alcohol is 120 ml. So this looks like alcohol. Okay. So what percent of alcohol is the resulting solution? What percent is the resulting solution? Okay. So here we have 120 out of the total volume. You have to find the total volume. Total. Okay. So the total volume here will be 120 plus 480. And that would be 0, that's 600 ml, that's the total. Okay. So what percent of alcohol? So we have 120 ml for the alcohol out of a total 600 ml. And if I multiply this by 100, you get a percentage. Okay. So that gives us, you can cross out zeros, 0, 0, 0, 0. So you have 6 into 120. So you have 20% of alcohol. 20% alcohol. Yeah. So that's how you deal with this particular question. It's like, what portion does it form? So part of the whole. 120 out of the whole, which is 600. Yeah. Okay. Good. All right, so we can continue with more problems. Let's page 117. Page 117. I believe those ones will be easy to do now. For number 1, 2, 3, 4, 5, 6 to 5. Should be easy for you to do those ones. So let's look through. If there's something that we can do easily, we can always skip that so I can do more problems as we go on now. All right, for number 1, it should be straightforward. Everybody, I believe. We did, there was an example like that. So somebody can give us the answer for number 1 and then we'll skip. So we're looking at page 111, number 1. So 23 beats in 15 seconds. How many times would the patients have beat in 1 minute? Anybody? 23 in 15 seconds. So you have 1 minute, 60 seconds. How many? So what will X equal to? Any of us?
It'll be 92.
92, yeah. 92. So 23 times 60 divided by 15. Okay, so 92. Okay. All right. So that one should be fine. Number two, I believe that one should be also a little bit straightforward to do. 3y is equal to 2x plus 8. Now they give you what x is. It's a x is equal to 20. Find y. Yeah. Then y is equal to. So in this case, it means I have to substitute for x and then solve for y. All right, so substitute and solve for y. So we have 3y is equal to 2 times 20 plus 8. So we have what? 3y is equal to 20 plus 20 times 2, that's 40, plus 8, so that's 48. And then we can divide by 3 to get y.
16.
Okay, so that should be 16, right? So that would be 16. (48) divided by 3, so y is 16. All right, good. All right. So I think number 3 you should be able to do it yourself. Number 3 should be fine. Number 4, adding 2 fractions. So we can use that to review fractions. Adding 2 fractions, remember always LCD. Okay, so we'll end on number 5 for today. So number 4, 3 3/4 plus 2 4 out of 5. Okay. So remember you need what? LCD. So write each fraction with the LCD. LCD here 4 and 5 will be 20. So this is 20, 20. How do I get 20 here? It's times 5 to the denominator, so times 5 to the numerator, so that's 15. Times 4 to the 5 here to get 20, so times 4, so that'll be 16. Okay. So if we add the whole numbers, we get 5 whole number. Add the numerators, so that'll be 31 out of 20. But this is an improper fraction, we can't leave it like this. So it means we have to change the mixed number. So we have to divide. So we have to divide 20 into 31. So 20 into 31, that will be 1. 20, this will be 11. So here we have one whole number, 11, remainder 11 out of 20. So we have to add the 1 to the 5. So now this becomes 6 whole numbers, and the fraction left to be 11 over 20. So this is what you get. 6, 11 out of 20. Okay. So remember, adding and subtraction fractions, LCD. You need the LCD. Okay. And then the last one for today, you find a volume. Volume of a cube. We had a cube, volume of a cube, which is number 5. Remember, volume is area times height for all volumes. So if I have a cube of a cube, the area, which is the base area, is the length times the width. So this length times the width. And then times the height. So length times width times height will be the volume of the cube. Okay. And which will be given here. So this will be 12 times 15 times the 8. If you multiply all this, then we should get the volume of that cube. Okay. So that should give us 1440, right? (12 times 15 times 8). So it's 1440. And the unit is centimeters cube. Now be careful, sometimes they give the answer, but the units may be wrong, right? If you're dealing with volume, you are doing the cubic. You're multiplying the unit 3 times. So it should be something cube. If it's feet, feet cube, and so on. Okay, it's a cubic, inches cube. So if they write squared, sometimes they give the answers. They write centimeters, centimeter squared, centimeter cube. They have to watch the units cube. If it's area, then area is centimeters squared or feet squared, inches squared. Because area is just multiplying 2 things, so it's a square and so on. So be careful with the unit as well. Okay, all right. So this is a good point to end for today. We'll continue and then we'll try to finish this second test next week. Any questions before we call it a day for today? Okay, so there are no questions.
No questions, but I did send you 2 emails last week and I don't think you didn't respond to them.
You did?
It was from my Gmail, not from my school account, because that's where everything for this class was sent to, my Gmail.